Okay, I know I said I'd buy me a quality welder. And I also know that this one is a kinda low-end machine. Thing is that I realized, whatever I bought, I could never beat this little thing. And the reason is this one. This little welder here was bought using Patreon money. The other day I cast out Patreon for the very first time. All your guys' pledges since day one. And the sum of those pledges was just about right to buy me this one. So it hit me. And if it was up to my back pocket, I'd get me the same exact thing with the only difference that it could also do gas. Argon. Okay, maybe it would also have a prettier duty cycle. But being upon this symbolism, I just couldn't resist. So I can now say that my patrons, you guys, bought me this welder here. And this is freaking awesome. I want to thank you all for helping this tiny place, our place, go mightier. Thanks guys. Now, as far as welding goes, I have done it a few times before, and mostly stick, but you cannot call me an experienced welder. Not at any case. But then again, this is part of what we do here. We learn stuff together. I mean, if I had an expertise in CNC machining and I owned fancy 5-axis machines, chances are you guys wouldn't watch my videos even if I made them. Sort of. So today you are not gonna learn how to weld, but if you are anywhere close to starting such a learning curve, hopefully you'll find something in this video to help. If you really know your welds and welders, I'm afraid this one is not for you. Next time, buddy. As you can tell by now, I'm gonna need some grinding. This is also thin metal, which makes it a bit tricky to weld. When it comes to welding two pieces of metal together, you have a heck of a lot of options. You can use fire, electricity, high frequencies, friction. Today we're gonna talk about just the cases where you use electricity to make your welds. It is the most popular way and probably the most convenient for guys like you and me. During this procedure you use electricity to melt your base metal, the two pieces you want to join, and form a bond. Most of the times you even add some metal in there to fill any gaps. As for the electricity you are using, it is low on voltage, high on current, so it won't shock you. In fact, any voltage under approximately 60 volts won't shock you. So these machines are actually power supplies. They take the juice out of your wall socket, to 20 volts in my case, and get it down to a lower voltage to give you more heat. I have a 16 amp breaker to this line powering the shop, but when my thingy here transforms 220 to 20 volts, I can easily get 130 amps out of it. And those 20 volts or whatever I can get between those two thingies, which are called electrode and just a clamp. Okay, I know, I am starting to sound like Wikipedia here. But don't worry, I will simplify things in a bit when we talk about different types of welders. But first let me point something out. All this metal melting and stuff you do when welding, you cannot just do like that, between thin air. Thing is that if the molten metal touches the atmosphere, it tends to oxidize and contaminate and all those nasty stuff. And your welds, they come out neither strong nor good looking, so you need to protect this whole process from the atmosphere, shield it some way. And now we come to the case. The way I see things, there are three types of welding processes. Stick welding or MMA, MIG or wire welding, and TIG welding, which is relatively new technology compared to the others. So stick welding looks something like this. Your electrode is that stick that was burning there, and as you go through your weld, it gets smaller and smaller, until it disappears completely. Then you throw up there a new one, and you continue welding. So your electrode in this case is a consumable. This electrode used in stick welding is this one, and it consists of a rod of metal, your filler, covered in that substance, called flux. During a weld, flux evaporates, and it becomes CO2, seals your weld, and doesn't let the molten metal come in contact with the atmosphere. After that we have MIG, or wire welding. The principle is the same here as stick welding, but in this case my electrode, instead of that metal rod covered in flux, is this tiny metal wire inside this torch. And again it is a consumable electrode, meaning that it burns off while I'm welding, which is why my machine keeps feeding me with this stuff while I press this button. Traditionally, wire welder electrodes have no flux, so we need to find another way to shield our welds. And there is already a way. Gas. Some sort of gas is provided through this nozzle around our electrode during welding, and it shields our weld. This gas is usually argon, but it's not always the case. But in some cases, like this welder I'm using here, the wire is hollow, more like a tube, and the center of it, the core, is filled with flux. This is called the flux core wire, and as you understand, it eliminates the need to use gas. In general though, welding with flux instead of gas is a dirtier and messier procedure. Those sparks you see flying around the place, you will not find those in a gas welder. On the bright side, using gas you cannot weld outdoors on a very windy day, let's say, as the wind keeps taking away all your precious shielding gas. And last but not least, we have TIG welding. And if I want to put this in a way that you will get it right away, TIG is what this old Tony likes to play with all the time. But just in case you don't watch that, TIG stands for tungsten inert gas and uses a tungsten electrode which is not consumable this time. Here is how it goes. You hold a torch in your hand which contains your electrode, one end of which you have grinded to be pointy. You get this point closer to your metal on which you have placed your other lid someplace, the clamp. When you are some millimeters away from your work, you press a button, a pedal, a switch, whatever, the kraken is released and you strike an electric arc between your electrode and the metal underneath it. This way you melt your base metals and make a weld. If you'd like to also add some filler material in this weld, you do it with your other hand. You just push rods of metal against the paddle of molten material there. And as for shielding your welds, again this procedure uses gas, which comes out of your torch and around your electrode. With TIG welding, you have maximum control over your welds, and therefore you can weld pretty much anything. Also, TIG can run AC, but we won't get there this time. On the other side, TIG is a rather slow procedure, and while I never gave it a try, I believe it requires some practice and quite some equipment. So what is the best welder for you? Depends on the type of work you want to do. If you want to make a big-ass trailer for your truck, stick welding will suit you just fine. In fact, it will even save you some money and quite some time. But if you want to make precision welds, and usually in a small scale, like a superbike frame let's say, TIG is your thing. And as for MIG, well, for me it is just in between. It is handier than stick and quite more precise, but not anywhere close as time consuming as TIG. You just press a button and feed wire into a weld. With MIG though, you cannot weld crazy thick material, and if you use it without gas, with a flux core wire, the precision you can get is not a whole lot more than stick welding. So you'll have to weigh it a bit. What would you like to weld? How much money you want to spend? Do you have the space for big ass gas bottles and regulators and stuff? I made this video because while talking with some friends the other day, I realized that there is some confusion around different types of welders. And I find that sometimes, when you're about to enter a field, the point of view of an also non-specialized fella can come quite handy. Anyway, that was all for today. Until next time, thank you all for watching and have a nice one. I have just released some fresh t-shirt designs. If you are interested, you can check them out in the links you will find down below. Next time.